Hello everyone and welcome to Kiru's online lectures. I am Kira Chamtani and today's topic is trigonometric functions part 7. See, in part 1 we studied introduction and measurements of angles. In part 2 we studied about the trigonometric functions. Part 3 we studied graph of trigonometric functions. In part 4 we studied trigonometric ratios of compound angles. In part 5 we studied transformation formulas. In part 6 in previous video we studied trigonometric ratios of multiple and submultiple angles, that is trigonometric ratios of angles 2A in terms of A and angle 3A in terms of A. Now in this part we are going to study about sine and cosine formulas and how they are used, their applications. So coming on to sine and cosine formulas. So the sine and cosine formulas are basically used in triangles. So this we are basically talking about law of sines, or we can say sine rule. So this sine rule says sides of a triangle are proportional to the sines of the angles opposite to them. Now triangle can be acute angled, it can be obtuse angled, and it can be right angle also. Like let's suppose this is a triangle with sides A, B and C. So this sine law states, sine law says, like I am talking about, if this BC side, that is A side, so the angle opposite to it is A, so it will become A upon sine A. The side of a triangle proportional to the sines of the angle opposite to them are proportional. They are in a proportion. So thus we can write A upon sine A equals, this side is B, angle opposite to it is B, so it will become B upon sine B, and then the third side is C, so it will become C upon sine C. So this we studied. This is basically law of sines, or we can say sine rule. This rule can also be written as sine A by A equals sine B by B equals sine C by C. Now the sine rule is basically very useful tool to express the sides of triangle in terms of sines of angle and vice versa. For example, this can also be written as A upon sine A is equals to B upon sine B, and this is equals to C upon sine C. We'll assume it to be equal to K, let's suppose. So the value of A will be K sine A. The value of B becomes K sine B, and the value of C becomes K sine C. Similarly, if this full value is assumed to be equals to K, so then sine A becomes K into A, sine B comes out to be K into B, and sine C comes out to be K into C. This is all about the sine rule. Now we'll see the questions also related to this rule, and the problems which are based on sine rule are basically like, we know this is a triangle ABC. If we are talking about sine A plus B, now since we know A plus B plus C is equals to 180 degree, so if we are talking about B plus C can be written as 180 minus A. So sine B plus C is equals to sine 180 minus A, and as we have studied in our previous video, sine 180 minus A is written as sine A. So these are certain formulas or the results which we can say of the sine rules. So sine B plus C can be written as sine A. Similarly, cos B plus C will come out to be cos 180 minus A. Now since cos 180 minus A will come in second quadrant, so its sign is negative, therefore we write minus cos A. In similar manner, we can write cos A plus C is equals to minus cos B. We can also write cos A plus B is equals to minus cos C. Same is the case with tan B plus C, which is written as minus tan A. Now coming on to the question part. So the first question is, in any triangle ABC, we have to prove sine B minus C upon sine B plus C is equals to B square minus C square upon A square. Now as we saw earlier, A upon sine A, this is sine rule, B upon sine B and C upon sine C, this is written as K. So the value of A will be written as K into sine A. Similarly, the value of B will be written as K into sine B and the value of C will be written as K into sine C. So now we will be solving the LHS part, that is B square minus, RHS part we will be solving, which is B square minus C square upon A square. So here B square will be written as K square sine square B minus K square sine square C upon K square sine square A. So I will take K square common. K square from numerator and denominator will be cancelled out. Now since over here it is sine square B minus sine square C, so it will be written as sine B plus C into sine B minus C. And in denominator we have sine square A. Now as we studied, sine B plus C can be written as sine A into sine B minus C upon sine square A. So this square and this sine will be cancelled out. Then again sine A will be written as sine B plus C. Thus here we got sine B plus C. So this is how we can prove using sine formulas. Coming on to next question. Next question says, in a triangle ABC, if A cos A is equals to B sine B, then show that either the triangle is isosceles or it is right triangle. Again coming on to the same concept, we have A by sine A is equals to B by sine B and this is equals to C by sine C. We will assume it to be equals to K. So the value of A will be K sine A, value of B will be K sine B and value of C will be K sine C. Substituting these values over here, that is in place of A and B, will write these values. So we will get K sine A into cos A is equals to K sine B into cos B. Sorry, over here the question is cos B only. So now we will solve it. Here we got sine A cos A. This K and K will be cancelled out. We will multiply 2 on both sides. So we will get 2 sine A cos A equals 2 sine B cos B. Now we know this is a formula for sine 2A. So sine 2A is equals to sine 2B. And this can also be written as sine 2B can also be written as sine of pi minus 2B. So here we will get two values. The 2A is equals to 2B or 2A is equals to pi minus 2B. So in first condition we got A is equals to B and in second condition we got A plus B is equals to pi by 2. Thus we got A is equals to B, or if A plus B is pi by 2, that means angle C is equals to pi by 2. So hence if A is equals to B, it can be written as BC is equals to CA or C is equals to pi by 2. So we can write triangle ABC is either isosceles or it is right triangle. Next question is, this is the question which is based on the applications of the sine formula. Next question says, a tree stands vertically on the hillside which makes 15-degree angle with the horizontal. Now let's suppose this is a tree. Now this PQ is a tree which is standing on the hillside, which is PR, and now this is making, this tree is making 15-degree angle with the horizontal, that is, it is making 15-degree angle like this. Now from a point on the ground 35 meter down the hillside, now this angle 35 meter down the hillside, this side is given to us 35 meter, as we can see over here. Down the hill from the base of the tree, angle of elevation of the top of the tree. Now from this point, angle of elevation of the top of the tree is 60 degree. That means this full angle is 60 degree. So the remaining angle, since this angle is 15, so this angle will come out to be 45 degree. Now since this full angle is 60 degree and this angle is 90 degree, and then this angle will be 30 degree by using angle sim property. So basically we have to find over here the height of the tree, that means we have to find PQ. So applying the same concept, now when we are talking about PQ, the angle opposite to it will be this PAQ. So PQ upon angle, that is sine of angle APQ will be, now we are provided with this side, that is AP. So side is AP, angle opposite to this is AQP. So we will write sine of angle AQP. This is how we applied the sine rule, and then we will get the height of the tree. Now substituting values over here, PQ sine APQ, it is PAQ, sine PAQ, because PQ is the side, opposite angle is PAQ. So sine PAQ is equals to sine 45 degree. AP is 35 meter. Sine AQR is sine 30 degree. Now when we will solve it, we will get PQ sine 45 is 1 by root 2. So 1 by root 2. Here we will 35 degree. Sine 30 is equals to 1 by 2. So the value of PQ will be 70 by root 2. On rationalizing, we will get 35 root 2. So this is how we can find out height of the tree, which is 35 root 2, by using sine formulas. Now coming on to law of cosines. The formulas for law of cosines, either we talk about any of the triangle, that is we are talking about the acute angle triangle, or we talk about your obtuse angle triangle, or we talk about right angle triangle. In all three cases, the law of cosines are also same. Like over here, the three sides of a triangle are A, B, C. This side is given as A, it is given as B and C. When we have to find cos A, so this is written as, since we are talking about cos A, so B square plus C square minus A square upon 2BC formula becomes. Similarly, if we are talking about cos B, in that case the formula becomes A square plus C square minus B square by 2AC. And when we are talking about cos C, so formula becomes A square plus B square minus C square upon 2AB. Coming on to next, that is the projection formula. In any triangle ABC, projection formula says any side of a triangle is equal to the sum of the projection of other side on it. Like I am talking about, this is triangle ABC. A, B, C, these are the sides of a triangle. So if I am talking about A, any side of the triangle, this A will be equal to sum of the projection of other side on it, that is sum of the projection of B and C. So B cos C plus C cos B. Similarly, if I am talking about B, that means when we have to write the formula projection for side B, so it will be written as A cos C plus C cos A. So C will be written as A cos B plus B cos A. So this is all about the projection formula. Now using these cosines formula, we'll solve some question. So the very first question over here using cosine formula is, in triangle ABC, A is equals to 3, B is equals to 5, C is equals to 7. Now we have to find the value of cos A, cos B, cos C. So the formula for cos A is equals to B square plus C square minus A square upon 2BC. So B square, that is 5 square, which is 25, C square 7 square, which is 49, minus A square, that is 9 upon 2BC, 2 into 5 into 7. So which will come out to be 70. So here the answer is 65 by 70. In similar manner, we will solve cos B. So the formula for cos B is C square plus A square minus B square upon 2BC, which is written as C is 7, 7 square 49, A is 3, A square 9, B is 5, B square 25. Upon, again it will be, over here it is 2AC. So it will be 2 into 3 into 7. So it will come 6 into 7, 42. Answer will be 33 by 42. So cos C, formula for cos C is A square plus B square minus C square upon 2AB. Here A square is 3 square 9, B square is your 25 minus 49 upon 2AB, 2 into 3 into 5, which is 30. On solving over here, we will get minus 15 upon 30. So this is how we can find out the value of cos A, cos B and cos C. Now coming on to next question. The question is, in any triangle ABC, we have to prove sin B upon sin C is equals to C minus A cos B upon B minus A cos C. Now as we studied projection formulas, so we'll solve over here the RHS part. In projection formula, C is written as A cos B plus B cos A minus A cos B. We have substituted the value of C over here. Now we'll substitute the value of B. B is written as A cos C plus C cos A minus A cos C. Now what we'll do, this and this got cancelled out. Similarly over here this got cancelled out. So we are left with B cos A upon C cos A. Cos A cancelled out. So we are left with B by C. Now as we know, if we are using sine formulas over here, sine rule. So by using sine rule, B is written as K sine B and C is written as K sine C. So substituting the value over here, in place of B I will write K sine B and in place of C I will write K sine C. K and K got cancelled out. So we got sine B by sine C. So this is how in this question we applied projection formulas on the cosine rule and we also applied the sine rule. Hope you guys are finding videos helpful. So do like, share and subscribe the channel. Thank you.